This is the last problem in the previous day's notes, example 6. In a certain locale, there are 2,345 confirmed cases of a virus. Wonder which virus that is. The number of confirmed cases at time t in days is given by n of t. The rate at which the number of confirmed cases is changing can be modeled by the differential equation. The change in n over the change in t equals 336,000th n. Determine an equation for n of t. This is the derivative. This is the original function. There's an ordered pair that there are this many cases of the virus. And then t is days after these confirmed cases. So that means this ordered pair that you see right, I should say this number you see right here, is implying the ordered pair n of 0 is 2,345. So we need to take this differential and we need to separate the variables, integrate it to figure out what n of t is. But before we do that, something that's been mentioned in the review so far that I have not pointed out, because I didn't know that you were allowed to jump to conclusions. And when I say jump to conclusions, I mean skip work. But it's been made clear in the reviews that you can. So before we do this problem, let me come at you sideways here for a second. If I take a function, f of x, and let's say that function is e to the 4x. If I take the derivative of this, I'm going to get 4e to the 4x. Notice, when you take the derivative of e to a function, you take the derivative of the exponent, which is 4, times the original function. This right here is equivalent to saying 4 times f of x. And that's because f of x is the same as e to the 4th. The only thing that changed here is this 4. With me? Let's say that we had, let me give you a different example. Let's say that we had g of x equals, let's say, 8e to the, I don't know, 9x. G prime, take the 9 times the 8, you get 72 times e to the 9x. This is the same thing as saying 9 times e to the 9x. This here is the original function. Keep also in mind, make this more clear, that f prime is the same as saying the derivative of f with respect to x. And I'm saying that's equal to 4 times f of x. Down here, the derivative of g with respect to x is equivalent to 9 times g of x. Here's the point that I'm trying to make and the people in the review sessions have made very clear. None of the stuff that I just did has anything to do with this problem. It has to do with understanding the relationship that's happening in this problem. If you're trying to find the derivative of n with respect to t, and that's equal to a number times the variable that's in the top, that means the original function for this is e to some exponent. Specifically, we would know that this function n of t is going to be equal to the initial value, which we'll get to in a second, times e. Now this is the derivative of the exponent. So that means the exponent is 0.336 to the t. And the initial value for a exponential function, the y-intercept, is the y value when x is 0, which is 2,345. According to the folks in the review session, we are allowed to jump to this answer immediately like that and be done with the problem. Once again, that happens when you have a derivative equal to a number times the variable that's in the numerator of the derivative. This is the initial value, and then this, let me see if I can write this in a better way. If the derivative of n with respect to t equals, let's say, a times n, and then we also know that n of 0 equals b, we'll say. Then n is going to be the initial value, which we're saying is b, times e to the a. Now, if that doesn't make sense to you, if you don't want to use that shortcut, don't use it. But this is going to save you a ton of time if you recognize it, and it's also going to save you the chance of making mistakes. You want to go old school? How would we have done this? Before I realized you were allowed to take these grand shortcuts, we would take this function, we would separate the variables. I'd multiply both sides by dt initially. So I would get the derivative of n is equal to 336 thousandths n dt. Then I would divide both sides by this little fella. And I'll tell you what, I wouldn't do that. I'd probably leave this on the right side. Let me do that. You could move it over. I mean, it's going to work either way. Then I would integrate both sides because we got our variables separated. On the left, this is natural log of the absolute value of n. On the right, we're going to get 336 thousandths t plus an arbitrary constant. And then we had this initial value up here. So we could put a 0 0 in for t, and then for n we're going to put 2,345. So that'd be natural log of the absolute value of 2,345 equals 336 thousandths of 0 plus c. So this is natural log of 2,345 equals c. So then once we get this, now please understand this is why if we understand how that pattern, that shortcut works, it's going to make our lives a lot easier. So then if we take this here and we replace c with natural log of 2,345, let's see, and then if we change to exponential form, so this has a base of e, so e to this exponent equals this argument. And then this here on the left, when you're adding the exponent, we can separate this into two things that we're multiplying. And then this right here, e to an exponent that's a logarithm that has the same base, natural log has a base of e. This just becomes 2,345. Then to get n by itself, saying it's the absolute value. So that means that n is plus or minus this mess. And we were supposed to determine an equation for n of t, and we'd have to choose the one that includes this ordered pair, and the one that's going to include that is the positive version. So our final answer for this is this fella right here. My highlighter is not working well. Or if you recognize the pattern, you're done with that as soon as you recognize what's happening here. This is the initial value, it's the y-intercept, and this is the constant or the coefficient that you have here at the beginning. If you need more work on this type of problem, like if you want me to give you like 10 of these problems that fit this pattern, you can just write the answer right away. I'd be happy to do that for you. Just